Hello grade 10 students, welcome to this video lesson. I am Madhu Vadke. We will continue our study in chapter 5, Arithmetic Progressions. In previous video class we studied how to find the terms of an AP and also to write down the nth term of an AP if the first term and the common difference is known. In today's video class, we will find an expression for the sum of first n terms of an AP. And using this knowledge, we will also find the sum of first n positive integers. So let's get started. To find the general expression for the sum of n terms of an AP, let's write down an AP that has n terms. So the terms of the AP are going to be A1, A2, A3, so on, and the nth term will be AN. Remember that an AP is list of numbers in which the next term is obtained by adding a common difference D to the previous term. So we can write this AP as the first term A, the second term as A plus D, the third term as A plus 2D, and so on, the nth term as A plus n minus 1 times D. Since we are finding an expression for the sum of these terms, let's denote this sum by S, and since there are n terms, the sum will be denoted as Sn. So Sn is equal to A plus D plus A plus 2D, so on, plus A plus n minus 1 times D. Now we will write this sum in the reverse order. That is, we will start with the last term as the first term. So the sum is not going to change because we are adding the same terms of the same AP, but in the reverse manner. So denoting this sum by Sn, we get the first term as A plus n minus 1 times D. What will be the second term? To get the next term in this AP, we added D to the previous term. So if I write the same AP in the reverse manner, then I need to subtract D to get the next term. So from this expression A plus n minus 1D, we will have to subtract D. So what do we get? We get A plus ND minus D, which is A plus ND minus 2D. We can take D common from these two terms, so n minus 2D. So in the second expression for the sum, the second term will be A plus n minus 2D. Likewise, you can write the third term. It's easy to guess now what will be the third term. A plus n minus 3D. And the last two terms will be A plus D plus D. Now we will add these two equations. So on the left hand side, we get 2 times Sn equal to, on the right hand side we will add the first terms of the two expressions. So A will be added to A plus n minus 1D, and that becomes 2A plus n minus 1 times D. Then we will add the second terms of the two expressions. You can simplify these two in the rough column. A plus D plus A plus n minus 2 D, I will multiply with D, so nd minus 2D. On simplifying this, we get minus 2D plus D will give minus D, which is same as 2A plus n minus 1 D. In fact, all the corresponding terms when added, that is the third term of the first list and the third term of the second list, when added will also give us the same expression. So we get 2A plus n minus 1 D as the second term of this sum. The third term will also turn out to be 2A plus n minus 1 times D. Likewise, the last term. The last term here is A, and in the first list it is A plus n minus 1 D. So on adding we get 2A plus n minus 1 times D. So all terms are identical in this sum. Now how many terms are there? Since there are n terms in the AP, we are going to get n terms in this sum. So adding n times is same as multiplying a single term by n. So we get 2 times Sn equal to 2A plus n minus 1 times D multiplied by n. So the sum Sn will be equal to n upon 2 times 2A plus n minus 1 times D. So this is the expression to find the sum of n terms. Notice that there are 4 variables. On the left hand side we have the sum of n terms. On the right hand side we have common difference. N stands for the number of terms and A for the first term. So if we know any of the 3 variables, using this expression we can find the 4th variable. The same formula can be written in a different way. Let's see how. The sum of n terms will be equal to n upon 2 times, I will write 2A as A plus A plus n minus 1 times D. But what is A plus n minus 1 times D? It is the nth term of an AP. So writing this expression as n upon 2 times A plus an. So we have another formula for the sum of AP where there are 4 variables, the sum of n terms, number of terms in the AP, first term and the nth term. Now using this knowledge, let's find the formula for the sum of first n positive integers. Let us write down first a list of positive integers. So it starts from 1. Next number is obtained by adding 1, 2, 3, 4 and so on. So let's say the last term is n of this list. So the first term is 1, common difference is 1, number of terms is n. So using this, let's find out the sum, which is 1 plus 2 plus 3 plus 4 plus so on till n terms. So using the formula, Sn is equal to n upon 2 times 2a plus n minus 1 times d, we get n upon 2, 2 into 1, substituting the values of a and d. On simplifying, we get n upon 2 times 2 plus n minus 1, which is n upon 2 times n plus 1. So, the sum of first n positive integers is n upon 2 into n plus 1. We can also call this as sum of first n natural numbers. With this knowledge, let us solve some problems from exercise 5.3. Question number 1. Find the sum of following AP up to 11 terms. Let's write down the information from the AP first. The first term is given as 1 over 15. Common difference D is equal to the second term minus the first term. So taking the LCM of 12 and 15, we get 60. 12 5 times is 60, so 5 multiplied by the numerator gives us 5. Minus 15, 4s are 60, so 4 times the numerator gives us 4. So D comes out to be 1 on 60. N is also given in the question, that is 11 terms. So we have all the information D, A and N to find out the sum of 11 terms. Write down the formula every time you use it so that it gets registered. So n upon 2 times 2a plus n minus 1 times d. Substitute the values. 11 upon 2 times 2 into 1 upon 15 plus n minus 1 will be 10 into d 1 upon 60. Simplifying the numbers, we get 11 on 2 into 2 on 15 plus 1 on 6. Now we have to add the numbers inside the bracket. So taking the LCM of 15 and 6, we get 30. 15 2s are 30, so 2 multiplied by the numerator, we get 4 plus 6 5s are 30, 5 multiplied by the numerator gives us 5. So we get 11 on 2 multiplied by 9 on 30, which can be reduced further. So the final answer is 33 on 20. Question number 2. Find the sum of these numbers. Is this an AP? It can be checked by finding common difference. The first term is minus 5 and common difference is minus 8 minus minus 5, which is equal to minus 8 plus 5, which is equal to minus 3. Subtract minus 8 from minus 11 and you will get minus 3, which means this is an AP. Now it's not given how many terms are there in this AP, but we know the last term. So the nth term of the AP is minus 230 and we don't know n. So using the formula for the nth term, we can find out n. So a plus n minus 1 times d is equal to minus 230. Substitute the values. Minus 5 plus n minus 1 times minus 3 is equal to minus 230. So n minus 1 times minus 3 is equal to minus 230 plus 5, which is minus 225. So n minus 1 will be equal to minus 225 divided by minus 3, which is equal to 75. So n minus 1 is 75, which means n is equal to 76. So the first term of the AP is minus 5. The nth term of the AP is minus 230 and n is, as we found, 76. So we can find out the sum of these n terms, which is equal to S76, by using the second formula, that is n upon 2 times sum of first term and the last term. So this is equal to 76 upon 2 minus 5 minus 230 gives us 38 into minus 235. On multiplying we get minus 8930. Question number 3 of the same exercise, subpart 2. In an AP, given that A is equal to 7 and A 13th, that is the 13th term is 35, find D and the sum of 13 terms. So from the question it is clear that n is equal to 13. A is given as 7 and the 13th term is given as 35. Using this information we can find out D with the formula A plus n minus 1 times D equal to An. So substitute these variables in this formula. 7 plus 12D will be equal to 35. So 12D will be equal to 28, or D is equal to 28 on 12 on reducing 7 upon 3 as D. Now we can use the formula for the sum of 13 terms as n upon 2 times the first term plus the nth term, where n is 13. So substituting n as 13, A as 7 and the nth term as 35. We get 13 on 2 into 42, which is 273. Question number 3, subpart 3. In an AP, the third term is 15. The sum of 10 terms is 125. Find D and the 10th term of the AP. N is given as 10. Now using these two informations, we will form equations in two variables. A3 can be written as A plus 2D equal to 15. So this is the first equation. The sum of 10 terms is written as, let's write the formula first. Substituting n as 10, we get 10 upon 2 times 2a plus 9d equal to 125, which is 5 times 2a plus 9d equal to 125. So 2a plus 9d is equal to 25. This is the second equation. We can solve them by method of elimination. So we will eliminate a. To do that, we will multiply equation 1 by 2 and then subtract the two equations. So equation 1 multiplied by 2 minus equation 2 will give us 2a plus 4d equal to 30. Copy the second equation as it is, 2a plus 9d equal to 25. To subtract, change the sign of the second equation. So a gets eliminated. We have minus 5d equal to 5. So this implies d is equal to minus 1. Now we can find the value of a by substituting d in equation 1, which is a plus 2d equal to 15. So a is equal to 15 minus 2d, that is equal to 15 minus 2 times minus 1. This gives us 15 plus 2, which is equal to 17. So we have d and a. We have to find in the question the 10th term. So the 10th term is given as a plus 9d, which is 17 plus 9 times minus 1. So 17 minus 9 is 8. With this, we come to the end of this video lesson. Your assignment for today is exercise 5.3. Subpart 4 of question number 1 and subpart 3 of question number 2 are already done in the video class. Remaining questions to be done as assignment. See you in the next class with more problem solving. Until then, goodbye.